Okay, so hello everyone. This is Shuzhe. So today I'm going to present the CLA2. And yeah, let's go on. Let's start with the data visualization using Tableau. So nowadays, big data is a very popular topic. And many companies will be mining big data to get user experience results, product development direction, advantages, and disadvantages. So how to make this deep data easily accessible to users is crucial. Tableau is a great choice for that. So it takes the Excel or other data files you dump into and automatically generates a visualization you want to present. It has a lot of different ways of presenting charts. Just click and select the model styles you want. The emergence of Tableau saves a lot of human resources, but also in this era of big data has an important position and replaceable value. Then we'll go with one example in sports for the visualization diagrams. So sports is a big business and success depends on increasing data. So for example, NBA is a sports business alliance. Tableau has become a much needed tool for this coaching staff or to analyze player and team data. It can quickly turn all the data into visualizations. So for most NBA players and coaches, their math skills are limited. Visualization diagrams allow them to simply and directly understand the overall strengths and weaknesses of their team. This saves a lot of time to analyze data and allows the team to put effort into practice as soon as possible. Then we will give an example in tech companies. So visualization diagrams help tech companies identify their weaknesses, respond to changing demand patterns by observing customer additions and churn, and predict which expansion strategies are most likely to be profitable. For example, Apple launches many products every year, such as Mac Pro, iPhone, Apple Watch, and so on. But that doesn't mean Apple is consistently profitable on every product. They can use Tableau to turn those sales data into graphics to analyze the strengths and weaknesses of their products. If mobile sales are higher this year, however, iPad sales are not, the company should make more production of iPhones and fewer iPads. So using Tableau in high-tech companies can help them avoid losses and maximize profits. Now we'll talk about cloud platforms. So AWS, Azure, and Google Cloud Platform are currently the three hottest cloud platforms. I will compare the advantages and disadvantages of all these three to discuss which platform is more appropriate and what circumstance and why Google Cloud Platform is a rapidly growing and promising cloud platform choice of the future. So first, I will talk about dedicated optical fiber network. So there's one area where the Google Cloud Platform could benefit from Google. It has access to Google's proprietary fiber optic network infrastructure, which generally provides better performance than standard network infrastructure. Not every GCP user will get this benefit. If you want to use its dedicated fiber optic network, you have to pay more. But for cloud platform customers looking for high performance networks, they will choose to spend more money using GCP rather than Azure or AWS because performance represents output. The money is well spent. AWS and Azure don't have that option. Another feature I want to talk about is that perhaps the biggest Google Cloud Platform difference that has emerged in recent years is the GCP's hybrid cloud and multi-cloud strategies. GCP has invested a lot of money in Ansible, a framework for running workloads across multiple private clouds. Ansible built an open source technology like Kubernetes, making GCP a flexible cloud platform company with multiple hybrid clouds. Azure and AWS, by contrast, are much less open to hybrid clouds. Their respective hybrid cloud frameworks, Azure Stack and AWS Outposts, are tied directly to their own cloud and don't help customers interact with third-party clouds. And then we'll go to clusters. So what is clusters? A cluster is a group of relatively independent computers that are connected to each other over a high-speed network. So when these computers form a team, They are managed by a unified system. These clusters communicate with customers, and the cluster becomes a server. So the cluster as a whole is constantly providing network resources to customers. We also have the benefits of using clusters, such as strong ability to expand, and the extension tag is easier to implement, and also it's easy to be managed and summarized. So then we'll talk about three common types of clusters. A high availability cluster is usually a complex cluster organization with two or more nodes. This type of cluster can still provide effective information and services to customers in the case of unexpected system failures. Load balancing cluster refers to the provision of load capacity proportional to the load nodes. Generally speaking, the majority of the network services will choose this cluster. The third common cluster is a supercomputer cluster. This kind of cluster mainly has high performance and fast speed. Then we'll talk about a comparison of descriptive, predictive, and prescriptive and analytics. So the most straightforward way to use descriptive analytics is to see what happened. It is based on historical data and real-time data to get a view of the future, which is to draw a conclusion after the fact. Predictive analytics is more complex and advanced. Today's popular statistics, data mining, and machine learning algorithms are using this kind of analytics to predict future possibilities. Prescriptive analytics is the next step of predictive analytics. It gives advice based on possible outcomes. So then we go to the classification and regression predictive analytics. So the classification of predictive analytics is to give different things a label, usually resulting in discrete values. For example, to determine whether an animal in a painting is lizard or a dinosaur. Classification is based on regression, and the final classification is usually determined by using the softmax function. On the other hand, regression is usually used to predict a value, such as house price, the future stock market, and so on. The common regression algorithm is a linear regression algorithm. Regression is an approximate prediction of the true value. So finally, we'll talk about the simple and multiple linear regression. So simple linear regression is used to explore the relationship between one dependent variable and one independent variable, such as the relationship between height and weight. While multiple linear regression is used to explore the relationship between one dependent variable and multiple independent variables, such as the relationship between height with weight, sex, age, and etc. Then we'll go to the summary and the conclusion. So today we talk about the visualization diagrams and its tools like Tableau, and also some examples in like sports and the tech companies area. And also we talk about three hottest cloud platforms, AWS, Azure, and the GCP. Also we talk about the types of clusters and its benefits. Then we go to a comparison of descriptive, predictive, and prescriptive analytics. After that, we talk about classification and regression predictive analytics. And finally, we talk about the simple and multiple linear regression. So here's a reference for my presentation. And that's it. Thank you so much.